This is a proof that the number of primes is infinite, and it's one of the two formal proofs that you have to know for A-level maths. Everything you need is on this one page, and I'm going to talk through so you understand the proof, but you need to be able to reproduce something like this or very similar to it. The proof is based on the method of contradiction. We make an assumption and then deduce that that assumption was wrong. So we're going to begin by assuming that there's a finite number of primes. So we can give it a number, let's say n. And if we've got n of these primes, we could list them. Might take a long time, but because there's a finite number, we could list them all side by side. And now let's consider constructing a number of all these primes multiplied together plus 1. And if we do that, none of the n primes are actually factors of that number, because for a prime number to be a factor of that number, it has to be a factor of both parts. And although every prime is a factor of the left part, they're not a factor of plus 1. So if this number that we've created has no prime factors, the only factors are 1 and itself, and so it's prime. But it's not included in our list of primes, because it's made of all the ones in the list multiplied together plus 1. So what that means is we didn't have all the primes in the first place. And that contradicts our assumption that we had a finite number that we could list. And so our conclusion is the number of primes is infinite. And that completes the proof.